Hello and welcome to Learning Plan 1 1.2 Lab. This focus of this lab will be on flowcharts. And so go ahead and open up 1.2 Lab, the HTML file, and also in your browser, Chrome or Firefox, and open it up in Visual Studio and put in your name, section, and email like I have here. And then let's look at what we're going to be working on in this particular lab. Now, before we jump into the actual lab, let me take a step back and talk about flowcharting in general. And I would expect you to read through this, but there's a couple things I want to point out. First of all, when we start programming, most programmers don't just dive right in and start building code. The reason why is because a lot of times if you start doing that, you get in trouble really quickly where you haven't thought things through, you make mistakes, you need to rebuild, so on and so forth. So using diagrams is a very helpful way to work through some of that logic and understand how your program is going to work. What's really great about flowcharts is it's language agnostic, meaning if I am building a program using Java and someone else who's a C# programmer wants to talk and learn about my program, I can show them the flowcharts, the diagrams, and they can have a perfect understanding of what the program is, not at the language level, but at the diagram level of the flow of logic and things. And you can have a discussion without getting bogged down in the actual code. There are several diagrams that programmers use. You'll be introduced to them as you go through your coursework here at NTC, such as a class diagram, object diagram, use case, sequence, and so forth. But today I want to focus on flowcharting. It's one of the basic building blocks of diagramming, and utilizing flowcharts, we can take a problem, a business problem for a program, and break that down, that logic down into the simplest steps so that we can understand exactly how information is going to flow through our product. So I have an example here where I talk, I won't reiterate this, I'll give you a chance to read it when you go through, but I talk about how our brains basically make logical, for the most part anyway, logical flowcharting decisions that as programmers we've got to break down into their common denominators that really our brains do very well, but we need to break down our programs to have them do it. Now, a couple things is I'm going to be using a program called Lucidchart. There's Visio, Microsoft Visio. If you have that program, you could use it. There's another online one called Gliffy. I'm going to give everybody access to Lucidchart so they can use it, and that's the one I'm going to use. But you don't have to use that. There's other flowcharting programs out there that you can feel free to use. But there's some standard symbols and things you need to be aware of so that, for example, when you start a flowchart, use I call it the squished oval, the start and end, and then as you're going through, how you make decisions is the rhombus, the diamond, processes are squares. So that we use these special symbols so that they mean something when we're doing the flowchart. And then I've got some tutorials on here. Again, I'm not going to take the time to go through those tutorials. You can do those on your own. But let me just go through. I want to spend some time going through some of these examples here, because we have not yet learned if statements, while statements, or for statements. We're going to. But I want to show you how those statements can be drawn out logically with some simple conditions, simple decisions. So an if statement, and again, don't get all bogged down into how the if statements, how the while statements, how the for statements work. I want you to understand how they can be displayed visually. So we have an if statement always tests a condition. Basically true or false. It's a Boolean condition. If it's true, do something else. Do something. If it's not true, do something else. So that can be displayed in a flowchart here, like I have here on the right. Start, test that condition. If it's true, do the first set of statements. If it's false, do the second set of statements, and then end up. Let me show you this example. We have our tomatoes. If the temperature is less than 32, then cover your tomatoes. If not, don't cover them. So we start off, we test, is the temperature less than 32? If it's true, let's cover the tomatoes. If that's false, let's not cover the tomatoes. So some basic logic. A while statement, we can do the same thing. While is actually a loop. While something's true, keep going. So we start off, while this condition is true, yes, run the process and check the condition every time. If that condition turns out no, bypass that process and end. So here's an example with our tomatoes again. While the temperature is less than 32, keep our tomatoes covered. So we start, Test our condition, is our temperature less than 32? If that's true, keep the tomatoes covered. If the temperature is still less than 32, keep on keeping the tomatoes covered. The moment that the temperature less than 32 statement is false, end. So that's the while example. Let me show you the for loop example. Again, we're going to go through these in some detail later on this semester. I want you to focus on how we can use flowcharting to understand some logic here. The for statement tests a condition similar to like a while statement, and as long as that statement is true, and there's usually a counter involved and stuff, with that condition we can run a process. So it's very similar to a while statement. So we start off, we test our condition. If it's true, run the process. Update our condition, come back up. Check that condition in, run the process, update condition, come back up. As soon as that condition returns false, bypass the process and end. Let me show you here. We're going to change from tomatoes to eggs here. So let's say we're looking at a carton of eggs. And so we're coloring eggs, and we're putting our colored Easter eggs into our egg carton. So we start off, and I ask the question, are not 12 eggs in the carton? The reason I'm asking that in the negative is I want to get back a true statement. False statements will not run, so I want to get back a true statement. So I can't say, are there 12 eggs in the carton? Because the answer to that would be false, because we haven't colored them and put them in there yet. So are not 12 eggs in the carton? In this case it's true, we haven't started. So we color egg, put an egg in the carton, come back up. Are not 12 eggs in the carton? That's true, there are not 12 eggs in the carton, there's only one at this point. So we color an egg, put an egg in the carton, come back up. Are there not 12 eggs in the carton? That's true, there's only two. So we keep on going until finally we hit, are not 12 eggs in the carton? Are there not 12 eggs in the carton? That would be false. There are 12 eggs in the carton at some point, and we bypass it and end. So we can use flowcharts to basically test out our logic and make sure we understand what we're doing in our particular program. So let's go back up and let's take a look at, go back to our lab here. So in our lab, here's what our problem. We were being hired by Fred to help out him and his boss Joe. So Fred sells a bunch of flowers at a local shopping center. Fred's boss Joe, he's the owner of the shop. He says, he comes to Fred and says, you know, he comes in periodically throughout the day, and he wants to know how many bunches of flowers have we sold, what's the most expensive bunch we've sold, what's the least expensive bunch we've sold, and what's the average value of bunches we've sold. So the first thing we got to do is we got to plan this out. Now in this particular lab, we're not going to actually be doing any coding. We're going to be building the flowchart. So what we're going to do is we're going to first of all plan some things out. So first of all, the variables. What kind of variables do we need? Now when you do this, I've already done this one. When you do this, your lists under variables, processes, and so forth are going to be empty. You need to open up the lab 1.2 lab file, come in and put these items in your list item tags like I did here. But I want to go through these. So we need to think through, okay, we've got 4 questions we've got to answer. How many bunches of flowers have been sold? What's the value the most expensive, the value least expensive, and the average value? So first thing is we need a variable for bunches sold. Since we're figuring out value, we need the variable for price. Since he wants to know the most expensive and least expensive, we need the highest and lowest price value. He also asked for the average, so we need an average price variable. And in order to figure out the average, we've got to figure out the total, because you know, if you sell 10 bunches at $5 a piece, you know, that's going to be $50 total value divided by 10. You got to figure out what the total is and divide it by the number sold. So that's why we have to have bunches sold, we have to have total value, and we're going to use that to figure out average price. And sometimes you do that, use one variable or a couple other variables to figure out a third. So we've got all our variables, and then our process. And again, do these here in these list items here in the code so you can see how that kind of works. So all these are list items. So our processes, now we have our variables, we have to figure out, okay, what's the process we're going to go through to actually answer these questions that Joe has, these 4. Well, the first step is we got to sell a bunch of flowers. So whenever someone wants to buy a bunch, we have to sell it to them. Then when we sell it to him, we have to maintain a count. So if he's wanting to know how many bunches of flowers have been sold, every time we sell a bunch of flowers, we have to keep track of that somehow in order to maintain that count. So when he asks that question, how many bunches have we sold, we can tell him. As we are selling them, we also need to keep track of the values so we can tell him what's the value the most expensive and the value the least expensive. We also need to maintain the average value of bunches sold based on the number and the total that we've sold. Then we have some decisions to make. We got to find out, okay, of all of our bunches we sold, what one's the most expensive, what one's the least expensive. And then we're going to have a loop where we're going to be selling flower bunches throughout the day. So let's think about this. A lot of times what you can do is you can write out pseudocode, and some of these planning lists and processes you go through can end up becoming not only your code itself, but also your comments surrounding your code. So from a pseudocode process, we got to think, okay, every time we sell a bunch, we got to increment our counter. We've got to keep track of the value of that, and we got to check that value to see if it was more expensive or less expensive than a previous value, so that we can say, well, this one's more expensive, so it's going to be the most expensive, or this one is less expensive, so it's going to be the least expensive. We got to, every time we sell a bunch, we're maintaining that counter, but we also got to keep track of our total value sold so that we can do some basic division to figure out the average. So you would create a loop that every time you sell flower, you do this. And this is where you start thinking, okay, what methods do I need? What functions do I need? What pieces of the puzzle do I need? Now, at this point in the course, I don't expect you to know that, but I want you to get in the habit of doing some of these flowcharts so that it becomes easier and the logic becomes more understandable for you. Now, one thing before we actually create the flowchart, I just want to go back and show you one quick thing. You may have seen it before when I was talking about flowcharting. This note right here. I want you, let me go back. I want you, once we've done this 1.2 lab and you do this assignment, I will be looking for flowcharts in your next assignments for the rest of the semester, and I want you to start doing them. And you need to do your flowcharts and your planning list and all that before you do your code. I don't know how many times that I've had students come to me, they say, oh, I'm having a problem, I can't figure this out, and I'll say, well, let's take a look at your planning list, let's take a look at your flowcharts to see kind of what you're doing so I can get on the same page with them. And they'll kind of shrug their shoulders at me, well, I haven't done those. Well, you need to do those. Those need to be done before you do any coding. So we want to get in the habit of doing these. Now, you're never going to do a perfect plan, a perfect flow chart, or whatever. These are to help you so that you can be as efficient a programmer as possible. So let's go back to our lab and let's see what we're going to do here. We are actually going to create the flow chart that Fred needs for Joe's flowers. Now, I'm going to be using this Lucidchart program, lucidchart.com. We can give you a sign-on for this, so you can use it. This is a great online program where you can create documents and share documents. You can tie it into Google Apps and Confluence, which you use in team software development here at NTC. But you can create all sorts of flowcharts and documents and diagrams, UML diagrams, class diagrams, and so forth. We use this quite a bit here, and we have a license for it, so you can use it as well for some of your projects. You can create folders and get into certain things and all that. So I'm going to jump into this lab for flowers here. And if you notice, when you first create, let me just go back one second, and let me just do show you how you can do a create new document. And you can start off with a template. I started off with a blank flowchart. And then you can pick categories over here on the left, depending on what you're trying to do. I chose flowchart. If you want to get into UML diagrams like class and use case and sequence diagrams and things like that, you can use these over here. And all those do is they get you started, and basically they give you the toolbox over here on the left with the tools that are recognizable for those types of diagrams. So here what I did was I drug a start out to show start, and then I went to the next thing, which I went right off of this list. So bunches sold, so here I have bunches, and I started off as equal to 0, that variable. I have a highest variable equal to 0, a lowest equal to 100, average equal to 0, and total equal to 0. Now, I show them all as equal to 0 except for lowest, because when we start our day, we haven't sold anything. So we have no bunches sold, we have no highest, we have no average, we have no total. Now, the reason I do lowest differently, there's a couple different ways you can approach this. As in a lot of programming, there's more than one way to skin the cat, so to speak. But lowest I start off as 100 because I know that's a really high number, and I may not sell any bunches that are higher than 100, so I know that when I go through my logic that number is going to get changed right away. From 100. If I started off at 0, I could never change it because I don't sell any bunches less than 0. So the next thing is I go through and do I have any bunches to sell? Yes, I do. Sell a bunch for a price, and then we increment our bunch count. Then we use what's called a compound operator, and again we'll learn about compound operators. They basically add to something rather than replace a value. I'm going to add, every time I sell a bunch, I'm going to take that price and put it in the total. So let's say I sell my first bunch for $2.50. My total is equal to $2.50. I sell my next bunch for $5. My total is going to be equal to $7.50. So I'm incrementing that up and adding whatever my cost is, whatever my prices are for my bunches. Then I get to figure out an average. Whatever total number I've sold from my bunch count, from my prices, my total divided by the number of bunches that I've sold. Then my next step is I got to figure out, is my price greater than the highest? Meaning when it starts off, my highest price is 0. So going back to my example, my first bunch was $2.50. My highest value was 0. So is my price greater than the highest? In this case, yes. $2.50 is greater than 0. So then if it's yes, my highest I set equal to my price. So now after my first bunch, my highest is $2.50. The next bunch I sell is $5. So is my price of $5 greater than highest? Yes. So set highest equal to my price, which is $5. Let's say the third bunch I sell is $4. Well, if I go into there, is my price greater than highest? No. So it bypasses it. And then I check if my price is less than the lowest. So it starts off, first one, $2.50. Is that less than the lowest, which we set at 100? Yes. So set my lowest equal to my price at $2.50. Next time it was $5. Is price less than lowest? No. So because it's no, we don't want to set our lowest price, and we bypass that no, and we come back up to here and start all over again. Either way, whether it's yes or no, I start over again, then when I'm done I end. So it's a loop that we're creating. So use this as an example. I want you to go through and create your own so you understand this logic in Lucidchart or Visio, whatever you want to create, so that you understand kind of how flowcharts work and how they can help you plan your program. The assignment for this, let me just show you, is I want you to create a flowchart outlining what you go through to get ready in the morning. So your alarm clock goes off, what's the next step? And outline all that you go through until you walk out the door to go to NTC in the morning for school. And you'll have if statements. If I get out of bed, if I've not gotten my clothes out of the closet, I get my clothes out of the closet, those types of things. And just be aware, take a step back as you're creating these flowcharts and read through them and see if they make sense to you. I've had students in the past that'll make this flowchart where, as they make the flowchart, the way their flowchart reads, they shower while still being in bed, or they leave the house without getting dressed first, and those types of things. So get used to using these flowcharts so that you can understand the logic, and it'll go a long way towards breaking down the logical processes so you understand how to program and how to have logical, thought out, well-built, elegant code programs. Thank you. If you have any questions, let me know, and happy coding.